Hi guys, coming at you with another video on graphing circles. In this video, we're going to talk about creating the equations of circles when we are given points on the circle. So, we're going to take a look at the equations of a circle, then we're going to look at a couple of different equations, then we're going to go over 4 examples. This is going to be probably a lengthy video, so keep in mind I will have a chapter off. Let's get started. In my previous video on graphing circles, I went into way further detail than I'm going to here. So if you want to understand this concept further, you're welcome to go check out that video, or the thousands of videos on the YouTube on conic sections. But essentially, conic sections come in 2 forms. They come in a standard form and a general conic form. We're going to be focused solely on circles, but in this case, we're going to be focused on finding equations of a circle when we're given a point on the circumference and or a diameter or radius. So the thing I would like to kind of discuss first is this clump of equations here. When we look at them, we should quickly notice that there are not any difference between them. Pythagorean Theorem is really what rules this situation. The distance formula and the standard form of a circle are just the Pythagorean Theorem rearranged in some way. Then we have the midpoint formula, which in my honest opinion makes things way harder than it needs to be. So let's take a look at our first example. So I want to write the equation of the circle, and in order to do that I need the radius first. The standard form, as I pointed out on the previous slide, is this here. Now, H and K are the center. So I have H and K right here, and I can go and plug them in for H and K. Please be mindful of the signs or the negative and positive values of your numbers. That is Y minus K. Placing -10 in for K makes that minus sign a positive. Now I need to find the radius. So the first way I'm going to do this is going to be with the distance formula. I will be honest here and tell you I am not a fan of the distance formula in the slightest. I find it is a very error-prone formula that students, struggling math students, including myself, have forever typoed this formula. Now I'm going to plug everything in. So the way I have to do that, I have to label this x1, x2, then y1, y2. I am sure there's a technical reason for it, but I don't know what it is. Oftentimes when they write the 1 and 2 subscript on the distance formula, they tend to write it 2, 1. The distance formula doesn't know the difference. And that is the first source of major typos here. If you write it backwards, 2, 1 on one side, you may accidentally write it the other way. Should it make a difference? It does sometimes, and just enough times to kind of mess you up when you're working the distance formula. The other problem with the distance formula is all these minus signs and negatives and plus signs and squares laying around. Kind of a recipe for a lot of mistakes. So I'm just going to do this longhand here. I'm going to get 9 plus 16, which then, whoops, didn't mean to delete that, is going to give me the square root of 25, which is then 5. So my radius squared is 25. That is one solution, one way to handle this problem. Let's take a look at how we would handle it with Pythagorean theorem. I am going to do this for the first two examples, then from there I'm just going to use Pythagorean theorem. But if you prefer to use the distance formula, by all means. I'm not here to convince you of otherwise, other than the fact that I just don't like the distance formula. If you want to use it, you are more than welcome to. So let's take a look at this. What I want is my change in x, or in this case, how much do I have to count from 13 to 16? And the answer is 3. I have to count 3 times to get from 13 to 16. I cannot subtract these. I have to count in the direction towards a number and figure out how many times I count. So 14, 15, 16, I counted 3 times. So that is 3 squared. From -10 to -6, I can count down 4 times. It honestly does not matter if you make your number negative or positive, because we're squaring it anyway. So, in other words, if you want to make the argument with me that from -10 to -6 is -4, that's the distance, I'm going to say go ahead. Because when you square it, it is going to be a positive 16. Now I have the c squared. Now you should immediately notice some parallels between the distance formula and the Pythagorean theorem. But this time, I don't have to square root anything. The 25, or r squared, appeared on its own. And the reason for that here is because when we're talking about formulas of circles anyway, r squared and c squared are the same thing. So it does save a little bit of time. But again, before we move on to the next example, I stress whatever is comfortable for you. Okay, the midpoint formula. It is one of those other formulas that students get reasonable control of but then forget, and we have a lot of issues with. So just hear me out a second, and I will write this down after the fact. How do you find the middle of anything? And the answer to that is you just divide by 2, or you half it. So in other words, if I want to know what the middle of 10 is, I divide it by 2 and I get 5. Okay, that rule doesn't change. The midpoint formula, which we know as this, is stating that in very complicated terms. So in other words, right, all I need to do is just say -7 plus 5, which is -2, divided by 2 is -1. And that's -1. 0 plus 16 is 16, then divide by 2 is 8. There is h and k. Now, if you want to plug that in, you are welcome to. I am not arguing with you. But what I am just trying to make clear is, it is a complicated way of presenting a simple idea. And maybe what it is here is that we want to, I kind of ran out of room over here, make clear that you are finding a point. Maybe it is just a universal way of communicating that this will be a point, but either way, you will get the same answer. So that is entirely up to you. Now, I'm going to just center this dot a little bit, so for this picture I'm about to draw. I did not show this before. I guess I could do the distance formula again, and let me just do that first before I show you guys the right triangles. So I have h and k. I'll write that up here. So I have x plus 1 squared. Then I have y minus 8 squared. And now I need that radius. The radius is honestly the key to a circle, because all a circle is a point with an infinite amount of radii around it, all equal distant. So without that radius, I cannot make the circle. All I have here is a point, kind of. Now, I'm going to use the distance formula. I will write it again in red for the sake of an evil connotation. And I will set it up -1 minus 5 squared plus 8 minus 16 squared. So I am going to end up with what looks like 36 plus 64, which then looks like the square root of 100, which would give me 10, which then I guess I would square again and get 100 here. Or I could use the Pythagorean Theorem. Okay, one thing I want to show you before I get started here. Kind of what's going on is I can create right triangles. So I'm going to create one here. Kind of like that. Okay? I could also create one here. So we'll go to that bigger triangle later. Now, what I have to do is establish a point here. What I am showing you right now is the complicated way to handle this problem. So, actually, I guess if I was to do this properly, I should really flip this. I actually don't recommend what I'm going to do right this second, but I want to show you where the sides come from. So the distance, this is actually really hard to read here, so I'm going to pick a different color. Okay, that's a little better. So the distance from -1 to 5 is 6. So that would make the length of this side here 6. Then the distance from 16 to 8 is 8. Or, like I mentioned earlier, I have to count. So I have to count 6 times to go from -1 to 5. And I have to count 8 times to go from 16 to 8, or either way. Now from there, I could plug in the Pythagorean Theorem. So I'm once again going to get the same numbers I did before. I don't really stress or recommend spending too much time on drawing out these pictures. It's kind of not worth it to me. I know that doesn't sound like much coming from me, when you could say, oh, well, you know your math, you know everything, you're really, really bright, you're so smart, and so good looking. And while those things might be true, I just find that the picture that I even just drew for you is very cumbersome. So it might be like more effort than it's worth. Alright, one more thing on this example that I would like to show you. Okay, let's just say that I did not find the center first. I found the length of the diameter first. It is not a big deal, but there's a few things to be aware of. The distance from 5 to -7 is 12. And then the distance from 16 to 0 is 16. Now, when I plug that in, I get 144 plus 256 equals c squared, and now that's 400 equals c squared. And if you notice that 400 is not twice as much as 100. Okay, let's talk about some stuff here. This red line, or this from this point to this point, is the diameter. Now, the radius is this line here. The radius is half of the diameter. Or in other words, you can write something like 1/2 d equals r. Okay, what's my point? That relationship does not exist here. And the reason for that is the exponential power took over. In other words, 2 times squared is 4 times, which is what we saw. In order to solve this problem, what you would need to do is you would need to square root 400 to get 20. Then to get the radius, you would have to divide that by 2 to get 10. Then you have to square the radius, so I would have to square the radius to create the 100, which is the radius squared, which you see here. Is it a big deal if you find the diameter instead of the radius? No. You just need to be aware of that step. No matter what, you still have to find the center. Okay, let's take a look at the next 2 examples, which I will do much quicker. The center and the point on the circle. So once again, I'm going to start with my standard form. I have brought this up in previous videos. I am not a proponent of memorization. But if you want to know how to memorize something, all you need to do is just write it over and over and over again and use it. And eventually it will sink in. So h is 12, so that's negative 12, and k is negative 4. Now my next step is I have to get the radius. If you want to plug into the distance formula, which I am just going to plug it in for you, you can. That will be something like 12 minus 13 squared plus 4 minus 5 squared. And you're welcome to do that. I am going to use the Pythagorean Theorem here because it is my absolute favorite thing to do ever. So, how many times am I going to count from 12 to 13? From 12 to 13, I count 1 time, so that's 1 squared. How many times do I count from 4 to 5? I also count 1 time, so that is also 1 squared. So now that means c squared is 2. That means my radius squared is 2. I'm not being asked to graph it or do anything else with it. I was just being asked to write the equation in standard form, so that's what I did. If you take a second, you will notice here that I will get the very same things, this time only in a negative, and I am asking for a bit of trouble here if I am not careful. Now, another thing I should point out if you're going to use the distance formula. Notice I am writing out distance here. The D often gets confused for diameter. You're not finding the diameter here, you're actually finding the radius. So that's why you see me writing DIST, to make sure I am clear, even for myself, for distance. Yet another hurdle I could avoid by using the Pythagorean Theorem. Let's take a look at the last example. Okay. The last example Also with No Pic. If you watch this whole video, you should pat yourself on the back that you made it this far because I've used a lot of words. Now, once again, you could use the distance formula and the midpoint formula. Or I could just quickly add 6 plus negative 12, which is negative 6, and then divide that by 2, and I get negative 3. 3 plus 3 is 6, then divide by 2 is also 3. If you want to see that written in the distance, midpoint formula, it will look something like this. And then you would get to the same conclusion. I'm not adverse to using the midpoint formula, but once again, my argument is just that it's one of those things that can get very confusing and is being made way harder than it needs to be. Now I need to find the radius. All I need to do is pick one of the 2 points on the endpoint of diameter. So this is H and K here. I can take those now and insert them into the standard form of the circle, which I've done right here. Okay. Now comes the point where I have to find the radius. I could plug that into the distance formula for sure. I could just pick one of these points. I have to be really careful and be consistent. So what I did here is I just picked these 2 points. If I were to pick the other 2 points, the results would be the same. So in other words, let's take a look at this using my favorite, you guessed it, if you've been paying attention, the Pythagorean Theorem. If I count from negative 3 to 6, I'm going to count 9 times. If I count from negative 3 to negative 12, I am still going to count 9 times. So in other words, what I am saying is negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6 is 9 times. So I counted 9 times. A great practice here is if there is a number line in your classroom is just to use that and count the number of slots. That might help you get more control over this. Either way, if you notice here, if I said 6 minus negative 3 is 9, I'm ending up with the same numbers. I'm going to count now from 3 to 3. Well, I can't count from 3 to 3. It's the same number, so that is 0 squared. That happens in both points. So there's a 3 here and a 3 here. So no matter what, I'm going to get 0 squared here, just like I'm getting 9 squared here. It's always the same, which is the true beauty of math. There is so many ways to do a singular thing. So now I'm getting 81 equals c squared. And that's it. I have my radius, 81. If you would like to go through the distance formula, which I am begrudgingly doing for you real quick, you're going to see I am going to get the same thing. So this is 81. Then I have to square root it to get 9, which then r squared is going to equal 81. Ended up in that box anyway. However you want to approach this, even though I love the Pythagorean Theorem. So I hope you guys have found this video helpful.